right, we're looking at equating coefficients. This is the alternative to long division or synthetic division. Okay, so we have a polynomial here. Okay, we have a polynomial here with 4 terms, all right? 2x cubed plus 7x squared plus 7x plus 2. And we have a binomial here with 2 terms, right? So basically what we're trying to find out is, what do we multiply with x plus 1, all right? What do we multiply with x plus 1 to get this polynomial here, 2x cubed plus 7x squared plus 7x plus 2, all right? That's what we're trying to find out. So we begin, right? You're going to open your brackets, all right? Open the brackets here, right? Then you're going to find out now, what do I have to multiply x to the power of 1 with to get x to the power 3? Okay, what must I multiply x to the power 1 with to get x to the power 3? Okay, because this is the highest degree in this polynomial, x to the power 3, all right? So we know we have to multiply by x squared, right? We have to multiply by x squared. So now the power of x is going to start decreasing. From x squared, we're going to go to x, okay, which is x to the power 1. And then we're going to go to our constant, all right? A constant is a number without a variable. So we're going to say ax squared plus bx plus c, okay, give us, when we multiply this with x squared plus bx plus c, we are supposed to get this polynomial here on our left hand side. But we must not forget to account for the remainder in case there is a remainder. And the remainder is always going to be a degree less, all right? It's going to always be a degree less than the x variable in the divisor, okay? So this x plus 1 here, this is the divisor, all right? And our x variable is x to the power 1. So our remainder is like saying x to the power 0, right? And remember, rx to the power 0 is 1, right? So we can just write our remainder as r. So always remember that the remainder will be a degree less than the variable in the divisor. All right, so now what we're going to do is we're going to expand this equation here on our right hand side. Okay, so we're going to say x times ax squared, we're going to get ax cubed right, plus x times bx, we get bx squared, right? Then x times c, we get cx, so plus cx, right? Then I'm going to say 1 times ax squared, we get ax squared, so it's a plus ax squared. One times bx, get bx plus bx. And then 1 times c, we get c plus c, right? Then we're going to say plus r, which is the remainder here. All right, okay, now this is the time when we're going to equate the coefficients. Remember, the coefficient is a number, okay, before any variable, okay? The variables are these letters x. Okay, the variable in this case is x. So any number or representation before a variable is a coefficient. So we're going to equate the coefficients from the left hand side with the right hand side. Okay, so when we look at our highest degree, which is x cubed, right, we equate the coefficients for x cubed. So we have 1 x cubed here in our on our right hand side, and we have 1 x cubed term also on our left hand side, right? So the coefficients of x cubed are a, all right, and 2, all right? So we're going to say a equals 2, okay? The coefficient is a here, the coefficient here is 2, so a equals 2, right? Then we go now to the coefficients of x squared, all right? So we have an x squared here and here, all right? And we have an x squared here, all right? So on our right hand side, we have 7. Okay, we say 7 equals, right? Then on our left hand side, we have a plus b. Okay, we have a plus b, all right? So since we already have our value of a, we're going to substitute a with 2, so we're going to have 7 equals 2 plus b. So we take this 2 over the equal sign, so we have 7 minus 2 equals b, right? And therefore b equals 5, right? B equals 5, right? So now we're going to our coefficients of x to the power 1, right? We have the c, we have this one here, we have this one here, and we have 7x, all right? So we're going to say 7, okay, equals, right? You can write it in any order. Maybe let's write it in this order. We'll say b plus c equals 7, all right? Just write it like that. B plus C equals 7. And B plus C equals 7. We have our value for B, which is 5, so we're just going to substitute. So we're going to say 5 plus C equals 7. 5 plus C equals 7. So C is going to equal to 7 minus 5. All right. And therefore C equals 2. Right. Now we're going to deal with our constants. Okay. Our constants. Right. So we have a constant 2 on our right hand side, and we have a constant c here, and we're also going to incorporate the remainder. So I'm going to say c plus r equals 2, right? We have the value of c, which is 2, so we say 2 plus r equals 2. Therefore, r is going to equal to 2 minus 2, right? 2 minus 2, and r equals 0. Okay, so we do not have any remainder. R equals 0, right? So now we've got our values. We're going to replace them in this expression here. Okay, this ax squared plus bx plus c. We're going to replace them in this expression here. All right. So our a is 2. All right. So our answer is going to be 2x squared, uh, plus, all right, our b is 5x, all right, plus 5x. And our c is 2 plus 2. And this is the other factor. So when you multiply 2x squared plus 5x with x plus 1, you are supposed to get this expression here.